Hello, my name is Tim Bennix, and in this ImageCon talk, I'll be going over the best practices of building a website with a low carbon footprint. The environment is super important, and as it turns out, websites are pretty big offenders in having a big carbon footprint, or a high carbon footprint with a lot of emissions. We cannot have that. We have the knowledge around us, so let's just put it together and build proper websites that are good for the environment. In this talk, we'll be going over all the details. So let's kick it off. All right, let's dive in. The title of today's talk is A Developer's Guide to Low Carbon Website, or to precise it a little bit more, how to make more sustainable choices in the production of web technology. I hope that after this talk, you'll have this.
Unagi.
So, for the uninitiated, here Ross in the TV show Friends thinks he has the unagi state of mind, which is basically he's aware of everything around him. So, let's talk about me for a second. My name is Tim Bennix. I come from Amsterdam. I was born in Amsterdam, and now I live in Paris. Here in Paris, I am the director of web development at Valtech, and I'm also a proud member of the media developer experts at Cloudinary. So, without statistics, a talk about the environment doesn't mean that much to me. So I thought, let's dive in and give you some numbers. So, if the internet were a country, it would be the world's 6th biggest polluter. So when I did the research, that was my response as well. It's like, wow, that's amazing. So turns out the internet consumes around 466 terawatt hours per year. Keep that in mind and then see that the UK only consumes around 300. Those are staggering numbers. So the average website produces 1.76 grams of CO2 emissions per page view. So for a website that has around 10,000 visits per month, that's a staggering, I say the word again, 211 kilograms of CO2 per year. This is crazy. We need to do something about this. So I've scoped this talk a little bit more towards a development production team and what they can do to make this better. So I have identified 3 areas roughly in which we can work. First, UX and design. Second, front-end development best practices. And third, architecture choices. So before we dive into the tips and tricks and the details, let's have a look at your website. Go to websitecarbon.com, fill out your URL, and have a look what comes out. I'll do it now for mine. So this really is a great website. The guys behind this site did a bunch of research, and if you go here, you can actually see how they did that and how they calculate everything. So let's type in my website. Oh, it's there already. Here we go. So calculate. So as you see, I'm doing this live. So I just released my new website. So let's see. It might not be as good as I hoped. Or, of course, I tried this before, but maybe they actually changed their algorithm. But I think, no, it's still the same. So basically, my website is cleaner than 90% of pages tested. That's pretty cool. I did, however, take a lot of time to build my website with all the rules I'm about to tell you in this video. So I only have a 0.12 grams of CO2, rather than the average 1.76 that we just talked about. So, and also I made the choice to have sustainable energy for the hosting I'm using. More on that later. So basically I would be creating almost 14 kilograms of CO2 in a year if I had 10,000 visits per month. Or I would have enough power to boil 1884 cups of tea. That's fun. One tree, this web page emits the amount of carbon that one tree absorbs in a year. Anyways, let's get back to the talk, but when you have some time, check this thing out because it's super cool. All right, let's go into the first category, UX and design and content.
Look, I drew a sketch of how we're going to do it, okay? Rach, that's you. That's the couch.
Ooh, what's that?
Oh, that's me.
Yeah, so UX, right? It's always a committee, it's complicated, whatever. So why did I choose this subject? Because actually, shitty accessibility and UX are pretty big offenders on websites that have a high carbon footprint. So if you make sure that your accessibility is spot on, your SEO is spot on, your content is very readable, people are in and out very quickly, and therefore they'll have a lower carbon footprint. So if your page is easy to find, if it's also easy to understand, people just use their devices less, right? There's much less resources going over the wire if you can find something the first try rather after 6 tries, right? So next to that, in the content, make sure you convey your message in as little content as possible. And sometimes that doesn't work, or sometimes you have to whip your storytellers into place a little bit of, like, you might want to tell a 10,000 page story, but it can be done in 2. So talking about whipping.
You know, whipped. Whoop-a! It's not whipped. Whipped is... That's what I did. Whoop-a!
Anyways, I just wanted to put this scene in because it's so much fun. And also you kind of have to whip your designers into place to understand all the technology, storytelling, content, everything together, right? I don't say whipped as a developer, just everybody together needs to be on point. So if you want to go a little bit more technical, the rough tool you can use to cover all your basics is the web developer tools in Chrome, and use your audits tab and just run an audit. You get a lot of bases covered that way. So let's jump into accessibility. This is a pretty big one that we need to deal with. If people want to find your content quickly, your website better be accessible. So what can you do for accessibility as a developer? First of all, have your code compliant to A or AA standards. I say code compliance, not compliance, because compliance itself requires an official agency to give you the stamp of approval and do that over time. That is very expensive. There's a lot of effort there, and it's also not always objective. Between Europe and the US, things are different. So if you go code compliance, so have no errors in your code, you have done a pretty big step already. Also, make everything relative. I don't want to see pixels anymore. We're only doing EMs, RAMs, percentages, stuff like that. And I'm saying this because a lot of people zoom their website. Most people that have a disability and need to see something better, they zoom like 200%. But sometimes your fonts don't zoom as nicely as your interface or whatever. So if you put everything together with relative elements of relative EM, RAM, stuff like that, it will grow properly. And one thing you have to worry about here is if you go and zoom by 300% on a big desktop screen, it's actually showing you a mobile interface. So make sure that your mobile design works with keyboard as well. That's a hard one, but you should pay attention to that. Next, SEO. Arguably more important than accessibility for easier finding of content. So this is a list of stuff, and if you implement all of those, you have again your basics covered. Extra stuff is again an agency that can help you, but just make sure you have your basics covered. And if you don't know what these are, I won't go into them in depth now because we only have half an hour, but just Google them and go from there. So make sure you have a canonical URL, have a proper title and description for the page, have a sitemap XML, have schema.org rich data, have proper OG tags, have no 404s or 500 errors, use HTTPS secure connection, have semantic HTML, and have a correct page outline. If you have all of those in place, you will no longer be on page 2 on Google where everybody dies. You will be on page 1. The only thing you have to now do is make sure your content is good. So, but I want to engage my users for as long as possible. I've heard so many clients of mine say that I want them to stay on the website, consume my content. But are you Facebook? Probably not, right? There's probably not really a reason for people to browse like 25 products of you that they weren't looking for. So I'll let Joey explain it.
Right? Because if he doesn't like you, this is all a moot point.
A moo point?
Yeah. It's like a cow's opinion. You know, it just doesn't matter. It's moo.
He speaks truth. But I know your boss likely told you my goal is to have people as long as possible to consume my brand. So if that's the case and you cannot fight back, which is normal, that's the way it goes sometimes, at least follow the guidelines for performance that we'll go into now. Let's talk web development best practices, as all web developers love to discuss, me included. So, performance on the front end has a big impact on the carbon footprint of your website. It's also one of the most visible ones, and it's the easiest for developers to tackle. So, not even 3 years ago, the average page was around 4 grams of CO2 emissions per page load. Nowadays, it's already down to 1.75. So over the past couple of years, we've done a great job getting better at this. We're still not there yet, however. So let's talk about what the biggest offenders are for a web page that doesn't have a low carbon footprint. And generally, that's the stuff we cannot really control in the development team. So think about third-party libraries, embeds, media assets, JavaScript personalization, tagging, systems like that. Generally, they're poorly optimized because they have to work everywhere, so they have a lot of features and they're bulky. And they might not use green hosting, and you cannot control that, right? And that's a big part of having a low carbon footprint. So what I would say is eliminate bloat. That's the only thing you can do to not have these. So really be selective of what you use. So try to remove as many third-party dependencies as possible. That's not always possible, of course, but in your own team you can. So do you really need all of Lodash or underscore? Do you need Moment.js with all its languages? Do you need Modernize or jQuery, Vue.js, React? Do you need all of it? Probably some of it, but not all. So really be vigilant on what you use. And if you do have to use a library, make sure it's modern and it supports import and export statements. Because then Webpack is magic, because you can say just load this part of that whole library, and then when I compile my code, only that small part is in your compiled code and not the whole library. Because bigger file size means more bytes over the wire, means more work for your device, which means higher carbon footprint. So have less, eliminate bloat. Actually, bloat-wise, I would say Google Tag Manager for analytics and front-end personalization engines are the worst. So I'll go over what they do, because Google Tag Manager is like an analytics tool that is really smart, because you add a little bit of script on your website, and then Google in its dashboard environment where you can select what kind of analytics you want, you can inject a whole bunch of code to deal with the website, because there's a JavaScript file there, so it has access to the DOM of your website. So people add in stuff all the time to do their analytics job. But generally, those people are not in your team, so you don't have control over what they put in. It's a similar thing for those personalization engines. So basically, there's another company that looks at A/B testing or stuff like that, and they would actually say, okay, this user has that cookie, that session. I'm going to inject this big chunk of HTML, or I'm going to add this bunch of CSS. And generally, the files that those systems come with are pretty big. They are really big offenders.
I'm wearing everything you own.
That's what they bring, basically. So it's generally people who are in marketing, who are really skilled at their job, but don't actually know anything about us as developers. So they bloat your website through those systems, and they have no idea that they just added jQuery, blah, 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 to just have one click handler. They didn't realize that. So when your website goes live, as a developer, you're happy, and then a month later to check and you get this.
All right, I don't want to alarm anybody, but Monica's hair is twice as big as it was when we landed.
I've had it time and time again when I check a week or a month after go live and suddenly my performance is down the drain because somebody added a bunch of stuff through Google Tagging Manager. So, controversial point. Most brands only use 5% of Google Tag Manager and personalization engines. Like, they have so many features, they are so advanced, but a lot of companies are not there just yet. Not everybody is Amazon, right? Maybe it's not worth the bloat. I understand that you have to, but with this information, you might be able to challenge that and have a lower carbon footprint. So, next, progressive enhancement. This is more of a way of working where you build the most simple setup, and then based on the features of your visitor's device, you can add some fancy features on top of that experience, which generally leads to not so much code. And then you have the other side of the equation, graceful degradation, which is I will build my blue sky vision with all the fancy features for the newest browsers with everything in place. And then I'm going to check for older browsers that are not as capable and add extra code to degrade gracefully so they have also a good experience. But generally that means there's more code. So progressive enhancement has less code, which means less data over the wire, less data for the processor of your device to interpret, so less energy consumption. So lower carbon footprint. Use this to build your website. Then one of the biggest of all is media optimization. Managing video and images is really hard. But the concept of what you have to do is fairly simple. Let's have a look. So optimize assets to have the smallest file size, the correct file type, and the correct resolution. And do this for each context that they are used in. This means that if you have on your mobile device, you're in, let's say, the Chrome browser, and you want to show an image full width, that means the resolution is around the size of your device. The file type is probably WebP because it's Chrome. And you have optimized it to a certain quality so you don't really see the bad artifacts on your small screen. But then when you go to Safari on a big screen, the file type is going to be different. The optimization is also going to be different because on a big screen, that's a retina screen, you might see something differently, right? Quality-wise. So per context, optimize the image to exactly what it needs to be. Don't have extra stuff to download. So that context of that idea is pretty simple, right? But then you actually have to do it. And this is where I feel like we're just incapable. It might be too hard with all the factors put together. Every project we have to figure this out again. And every time I have to explain it, I have to look it up myself again. It's kind of funny, right? That on the one hand, we have Google Stadia, which is the new gaming platform by Google, where they basically can stream 4K footage, 60 frames per second, with low latency while you are playing the game as a user through a browser. Right? This is like the peak of technology at the moment. And on the other hand, we cannot even show a simple image because that PNG that should have been a JPEG is 4 megabytes and it's stretched. I've seen many websites with this. Like, how can we be so advanced in one end and so not advanced in the other? We really need to step this up. So you can try to DIY your own like optimization pipeline that also resizes images and stuff like that. I've seen a lot of companies do this, but it's very expensive, it's time consuming, and you're always kind of behind because you have SaaS platforms like Cloudinary or like TwigPix or like ImageIX, and there's a bunch more that actually have done all that homework already. It's their business model to manage media for you. So it might not always be a digital asset manager like a DAM, even though some have it, but it's more about the delivery, and that's one of the hardest bits. So they are cheap. Just use them and have such a big improvement in your performance. So next, lazy load all the things, including the images we just spoke about. So if a user doesn't use something at that point in time, don't load it. There's no need for them to waste the resources. If you have a mega menu that pops out, and when it pops out, there are some images, don't load those images on page load, because most likely the user is not going to open that menu, because through Google they found already what they were looking for because you had good SEO. Don't load those images. So only when the user needs it. Don't waste resources.
Do we dare?
We dare.
So Joey and Chandler are actually chilling on their lazy boy chairs here. So lazy load all the things as much as possible. So images, video, iframes, third-party libraries. By third-party libraries, what I mean is if you have to load, let's say, a YouTube embed, or you have a system like Bazaar Voice that has reviews, ratings, comments, stuff like that. If you load that on page load and you put the script in the header, the page waits, loads the script in and does a bunch of stuff. And generally those things, like let's say the comments are on the bottom of the page. Just let the user scroll down, and when they come to the place almost where those comments need to be, then load it in. Because there's quite likely that they will never see that part of the page. So don't load it yet. One thing though is really beware of GDPR, because sometimes some scripts have to be loaded to check if there's an opt-in or somebody gave consent with their cookies. So don't lazy load so much that you're not compliant to GDPR anymore. That's actually very important.
All right, check out this bad boy. 12 megabytes of RAM, 500 megabyte hard drive, built-in spreadsheet capabilities, and a modem that transmits at over 28,000 BPS.
Oh, the 90s. They were awesome. Anyways, let's talk about server architecture and making the right choices there. So I think our current model is pretty bad for the environment. And lately, a lot of different models have been popping up, and I think they can help us here. So let's talk about those. So this is what we have at the moment, the monolithic application. So that's basically one big juicy package that has everything from web service to CMS to extra services to databases to your whole front end. Everything is in one big nice package. As you can see, there's a bunch of arrows in between, so there's a lot of activity going on. Everything is always on. It keeps state of each other. It knows, and it's just this one big beast that spits out an HTML page, basically. There are some issues here, so I won't go too deep, but let's go over them quickly. So cost, performance, security, power consumption, and scalability. Cost mainly because there's a whole bunch of special stuff within that big package, and it's always on. It's expensive type of stuff that you need that always needs to be on. For every page that you hit, something happens there, right? So that's just it's an expensive approach. Also performance. These things can really perform, but generally when you have a page that has all this dynamic stuff behind it with those servers and you click on something, it needs to go all the way back into that thing and come back to you and give you something. And generally now we have this optimized, but there's a lot of energy involved in doing that. Then security. If you have such a big system, there's a lot of surface area to attack. You have all those services running at the same time, and when you go into one, you can probably hack into all of them. Not everywhere, but this is possible. Think about WordPress or these kind of systems. They're the most hacked systems ever. And they rely on this monolithic system. I don't think in the future, and nowadays they're pretty good, but that is the history. They have a lot of power consumption because, like I said, they were all on. They're constantly keeping state. They're constantly that the power is churning, right? And then scalability. So if you hit Christmas, you're going to have to pay the big bucks to some company that helps you out to do load balancing and then having multiple of those environments up and running and crazy scaling stuff. It's very complex. It's not, let's say it's not easy to scale, and it's also not cheap. So I would say Gemstack to the rescue. Gemstack is not the savior of everything, but for a big chunk of the websites out there, it can really help. So just like I said, it's not for all websites, but it can cover a lot of them. So Gemstack is JavaScript, APIs, and markup. So the simplest thing, how I can explain it, I think, is what you do is you have locally on your machine or in the CI, the build system, you build your code, right? That code is built and then you push it to GitHub, or whatever Git you use. And you have all your information in there. And then at build step, at build, it will actually take all your data and compile that into a static website. So the dynamic bit, the state keeping the complex stuff, is only at build. And then once it's been built, you what you're left with is a chunk of files. There's a bunch of files that are static: HTML, CSS, JavaScript, images, fonts, stuff like that. Then that would actually be put on a CDN edge. So that means there is no origin server of which the CDN grabs the information to show that to users, because there's no need for an origin because everything is static. That means right now when I hit save on my website, it goes to GitHub. GitHub then talks to Netlify in my case. Netlify says, hey, there's a new change. Let me just rebuild that front end, get all the data. In my case, all the data comes from GitHub, but that could also come from other places. It generates my whole website, makes this nice little package of static files, and puts it on 30 places around the world for everybody to see. This is basically a very simple approach to go to a static website, which means if you want to scale this, you have to put those files in different places or in more places. There's no extra cost there. There's no running services. There's no origin. It's basically decentralized, and all the complexity is internal in my build system. That's where I get my data and get stuff. And I would say if you look at most websites out there, they could run on the Gemstack. And especially if you add extra SaaS providers, like having a headless CMS where content editors can still have the feeling of editing something, and then when you hit save, you would actually do that whole build system every publish, and then output again a static website. Or you can, if you have to have people logging in, you can add identity providers, you can add a whole bunch of third parties around it that still make this system a decentralized system. And it performs because of that. Because if you use the identity provider a lot, you only have to scale that identity provider, not the rest. So if you don't use something, you pay less. If you use more of something, you scale that little chunk up and pay only there. So this is kind of a nicer approach to the architecture system. And I know that a bunch of my colleagues are rolling their eyes right now, because I am working on global platforms that sometimes have 200 websites under the same umbrella that all reuse their code, and there's very complex personalization going. There's all this stuff. I know, guys. I work on them every day. But there are still ways that we can actually get this stuff to work. For example, if you use Uniform. This is a company started by my friend Alex Shiba, who used to work at Sitecore and knows that system really well. And now they have built a shell in front of those big systems that can actually make it a Gemstack website. So I'm not saying this is like the unicorn out there, it's perfect. Definitely not. There are still use cases that warrant you to have such a big enterprise system, clearly. But again, probably 80 to 90% of the websites out there can work on a Gemstack-like approach. So next one is look at something called serverless. That's kind of a funny term, right? But that actually grabs back on not having this origin server, but having everything microservice. Like this goes as small as having a function as a microservice in the cloud. So it's a simple, stupid, stateless function that has an input and an output, and it doesn't know about anything else. And if you don't use it, it's off. When you use it, it turns itself on, and only then you pay for it. So you can actually do simple actions, completely decentralized with these things. And if you do them a lot, you can just scale those things a lot, but only that one. So basically you can connect them all up if you want to, and you have to orchestrate them, and then you have profit, because it's such a nice approach to building an architecture in the cloud. Of course, guys, there is an elephant in the room here that we didn't talk about yet, which is server parks. You know, those server parks that are underground, they need cooling, they need security, they need protection, they need redundancy, backups. There's so much power going through those things. By default, CDNs and server parks don't have a low carbon footprint. So if you do use any of this, try to find one that puts itself as I am a green hoster or a green CDN. And that doesn't mean that their servers are green, but they are most likely carbon positive as a company or some sort of thing to offset it. And there are some server farms that are actually lower in carbon footprint. So make sure you choose those. And also make sure you persuade your clients to use the same. Because in my case, where I work, we have those big infrastructures that clients already have and we work on them. So we cannot always choose, but make sure that you persuade your clients to actually change it all. So we have a better environment in 10 years, hopefully, or not worse. So let's conclude. Actually, based on what I've just mentioned, it's not that hard. The concepts are easy to grasp. So follow general UX and SEO guidelines, follow performance guidelines, reduce the bloat, deal with media assets, choose the right architecture, and choose a green hoster or CDN. That's it, guys. It's not that hard, but all of it together, of course, has some effort. So I hope this video helped you to at least understand what needs to be done. And good luck building your websites. See ya.